Good day to everyone joining us, and welcome to today's Xtalks webinar. Today's talk is entitled Mastering Fats, Oils, and Grease, Essential Strategies and Techniques for Regulatory Compliance. My name is Sydney Perlmutter, and I'll be your Xtalks host for today. Today's webinar will run for approximately 60 minutes. This presentation includes a Q&A session with our speaker. This webinar is designed to be interactive, and webinars work best when you're involved, so please feel free to submit questions and comments for our speaker throughout the presentation using the questions chat box, and we'll try to attend to your questions during the Q&A session. This chat box is located in the control panel on the right-hand side of your screen. If you require any assistance, please contact me at any time by sending a message using this chat panel. I'd also like to welcome our attendees viewing this presentation from our LinkedIn Live event, and I encourage you to submit questions as well via the comments tab. At this time, all participants are in listen-only mode. Please note that this event will be recorded and made available for streaming to those who registered on xtalks.com. At this point, I'd like to thank ACO, who developed the content for this presentation. ACO introduced the concept of modular trench drains to North America over 30 years ago. Today, ACO in North America is a multi-site manufacturing and sales operation using a variety of materials for its extensive range of drainage. ACO products are designed and manufactured with the belief that the company positively impacts the use of one of Earth's greatest resources, water. Now, I'd like to introduce our speaker for today's event. Scott Forsyth is an experienced executive specializing in business development and strategic growth in the building drainage sector at ACO, with a focus on grease management. As business development leader at ACO North America, Scott directs the sales strategy and implementation of grease management solutions across the continent. He has built strong partnerships with major clients such as federal government agencies, Costco, Walmart, Sam's Club, McDonald's, and military contractors. And now, without further ado, I'd like to hand the presentation over to you, Scott. So take it away when you're ready.
Great, thank you, Sydney. Thank you, Xtalks, and thank you to everyone that has joined today's presentation. We are going to be digging into everyone's favorite topic, fats, oils, and greases. The topic today is really going to be around kind of understanding some of the technologies, kind of the environmental compliance, and some of the really sort of in-depth pieces to perhaps if you're a restaurant owner, if you're an end user, the revolving around kind of the use and the evolution of grease. If you kind of look at the screen, you're probably looking at this large mass, and you're kind of wondering, why are people walking around it with, you know, hazmat suits? And this is a term. It's called a fatberg, and it's a huge sort of clump of grease. It is being sort of combined with sort of kind of sanitary ware, things like that, that have got down into the drains. And ultimately, it is being collected and is causing a huge kind of problem. London actually pulled out a sort of a 14-ton, basically the size of a double-decker bus, and they put it on display to really highlight the impact of fats, oils, and greases on the environment, and kind of a showcase to the public that, you know, this is something that perhaps we don't see, but it is impacting our environment. There's a statistic, about 8.5 billion pounds of grease enter or exit the kind of the fast food or kind of quick service providers into the sewer systems and into the sewer systems. So today's purpose and agenda, we're basically going to be looking at kind of the challenges, the regulations around fog, fats, oils, and greases. We're going to be looking at some of the technologies with regards to implementing and dealing with this pollutant in the environment. You know, and if you're kind of sitting here wondering, you know, why is this important to me? Really what I'm focusing on is the end user, right? The person that is having to deal with this in their restaurants or their their food service facility. And, you know, I'm going to be sort of looking at why should we care? Like, what are the environmental impacts? What are the regulatory frameworks? What are some of the technologies that we need to understand? And then ultimately, what is the future for this industry? When we look at fog in the environment, for as long as, humanity has been cooking food, we figured out a long time ago that, cooking food, ultimately, it gives us better nutrition, certainly tastes better. But, there is a production, there is a byproduct, and this is sort of fats and oils and grease. And it's kind of something that we have to deal with on a day-to-day basis. Fog is ultimately, for those who maybe are new to the industry, but there's a term that's kind of used to sort of describe, fats, which are certainly byproducts from things like meat, margarine, butters, oils. We use them in salad dressings. We use them to kind of cook food. And then ultimately, the byproduct of all of these combined is kind of when you have the liquid, the combination of these, it tends to turn into what we call grease. And grease is kind of what we're focused on today from a management standpoint. Why should I care, right? I mean, so certainly we look at the environmental impact of greases on our environment. There is a huge cost with regards to actually dealing with grease in our sewer systems, in our piping networks. But at the end of the day, maybe if we kind of take it down to more of sort of the surface level, if you are a restaurant or a food service provider, you may be dealing with things like clogged lines or jetting lines, or maybe you have an inspector showing up at your door saying, hey, you need some kind of device to deal with your fats and greases. And at the end of the day, we sometimes look at the environmental impacts as something that's a little further out. It's something we want to sort of comply to work towards, but there's more of a basic level, and that is, it impacts our business. When we look at kind of how we break down, fog, there's kind of two big contributors, I would say, to fog. One is certainly through the kind of residential channel. I cook at home, and perhaps I've cooked something, I have a lot of grease or oil at the end of it, and perhaps instinctually I know, I shouldn't put it down the drain. It's going to cause a problem, right? So there's an aspect of fog in the environment that certainly has contributed from a residential standpoint. Estimates are about 50 to 70% of fog entering sewer system is from residential use. Commercial fog is primarily from restaurants, anybody that's kind of cooking foods at a larger scale. Roughly about 30 to 50% of fog entering sewer systems is a contributor from this segment. But really why this segment is important is because of the concentration of fog, right? Estimates say that about 16,000 pounds annually per establishment is what's generated. Now that can vary on the type of foods that you're cooking. And that's why we're kind of focused on this segment from a compliance, a regulatory standpoint. And that's kind of where I'll be focusing on today's presentation. Some of the things that actually discharge fog into our environment, things like wash sinks, dishwashers, ovens, rotisseries, any sort of thing that you're using to cook your food, that really is what is contributing to the overall kind of fog outload of restaurants as well. At the end of the day, you got to kind of look at your restaurant. You've got to kind of look at the system in which we work in, right? And I'm talking about restaurants, pipes, sewers, water facilities that are kind of treating the wastewater, sort of as like a human body, right? It is a system. It's a system of pipes. It's a network, and fog in itself is, when it cools, it congeals. A bit like your arteries, right? It's sort of, it starts to layer and layer. Different things kind of get caught within that sort of matrix of fog. And, kind of going back to that image of that fatberg, right? That is kind of exemplifies just how big the problem can become. And ultimately the time and the energy in which people need to put in to deal with this issue. So, kind of just creating some context of kind of what you would look like if you were looking at, perhaps just within your kitchen, the contribution of fog in the system. As we kind of enter out of that piping network, we obviously enter into things like sewers, that are carrying things like sewage, that are carrying other kind of wastewater down into water treatment facilities. And, again, the collection of fog in these arterials become really kind of a big problem for cities to maintain. They're expensive, they take time, and there's, like I'd mentioned, there is a lot of it flowing out and collecting in sewers. Ultimately, when we look at what we call SSOs, which are sanitary sewer overflows, this is where you might be looking at, a utility cover, it's raining, stuff is kind of bubbling out of it. There is a big contributor. About 40 to 60% of all SSOs in the United States are contributed towards fog, essentially, and grease kind of being trapped within those systems. There are other kind of issues that sort of fog contributes to. I mean, there is obviously smells that will come from the different piping networks. Corrosion is another big piece to it. So, fog in itself can cause corrosion, and ultimately it becomes kind of a big issue for cities to maintain. Again, when we look at sort of the overall picture, we look at the amount of issues that are caused by fog in sewers. It is not only time, but money. There's an estimate of about 25 billion in the annual costs that different cities around the country are, spending essentially to deal with fog-related issues. Another important component of fog is, if it does sort of get out into landfills, out into the environment, as it kind of breaks down, it creates methane, which, as I think the majority of people know at this point, is an incredibly potent contributor to greenhouse gases. So certainly fog in the environment, is considered a pollutant. Just like if you were pouring chemicals down the drain, we look at it in the industry and also from the legislative standpoint as a pollutant in the environment, and something that we kind of need to tackle and deal with as well. As we kind of move down that sort of the kind of the piping networks, wastewater treatment plants are where we ultimately get to from the standpoint of, has to deal with all of this wastewater, right? And fog in itself is certainly, is not good in wastewater treatment facilities. And part of that is because there's a lot of processes in which we have to deal with wastewater. There's filters, there's screens, there's bacteria that are specifically focused on breaking down different elements of that wastewater. And fog and fats, oils, and greases within that system is not necessarily the main focus. It can cause a lot of different problems in the system. And really more importantly, it can affect the effluent quality or the outflow from the facilities. And this becomes a problem, right? Because if you are affecting the quality, you're not necessarily meeting sort of federal regulations with regards to treating water at the wastewater facilities. So from a wastewater facility standpoint, rather deal with fog at another spot, which is further up the stream. And again, it's time and money that they have to deal with regards to treating those. I'm going to pause for here for a poll question.
All right. Yes, we have our first poll question that is appearing on your screen if you are attending via GoToWebinar, and you can vote by clicking on any of the answers. And for those of you watching via LinkedIn Live, please feel free to share your thoughts and answers in the comment section. So that first question we have for you is, have you or your organization experienced issues related to fog in your wastewater system? Please select one of the following answers. Yes, frequently, yes, but rarely, no, never, or not sure. Now that question again is, have you or your organization experienced issues related to fog in your wastewater system? Please select yes, frequently, yes, but rarely, no, never, or not sure. So I'll give our audience another couple of seconds to get in their votes. All right, and I see our audience has voted, so thank you very much for participating. I will close the poll and share those results. So we have 33% for yes frequently, 33% for yes but rarely, 33% no never, and 0% for not sure. So thank you very much for voting, and Scott, back to you.
Great, thank you. Yeah, so really what I just went through was sort of putting the idea and kind of out into the audience is that, really fog in itself is a pollutant, right? And there is a regulatory framework that really deals with fog in that focus, right, as a pollutant. In the mid-century, kind of mid 20th century, waterways throughout the United States there was really a big issue, right? I mean, the Chattanooga River caught on fire multiple times. The Chesapeake Bay, which was a huge, vibrant water body, was essentially dead, right? And the federal regulators kind of looked at this and said, we really need a stronger framework to deal with pollutants that are entering into really important waterways throughout the United States. And that was really the invention in about 1972 of the Clean Water Act. And the Clean Water Act was certainly one of the key legislative pieces of work that really dealt with environmental impact of pollutants. And really, at the end of the day, fats, oils, and greases were brought into that sort of matrix of different pollutants as one of the contributors to these environmental issues. The National Pollution Discharge Elimination System, NPDES, really started to look within that framework of the Clean Water Act of going, okay, well, at these water bodies, perhaps there are contributors at, let's say at the river, but there's stuff happening further upstream, right? In all of these watersheds, in all of these cities, they're all individually contributing to a larger problem. So the thinking within that framework was, how do we go to the source of the pollutant? Rather than trying to treat it further downstream and kind of regulate there to say, hey, listen, if you're going to be discharging, chemicals, if you're going to be discharging fats, oils, and greases, you've got to kind of deal with that pollutant at that source. So really, that was the framework of the Clean Water Act. And when you think about this is really the legislation that kind of drives all of these things that we do in this industry when it comes to fog. So again, if you're a restaurant owner and you have an inspector that comes in and says, hey, I need to, you need to put in a grease trap or something like that, this is kind of where it's coming from, right? You've got to deal with it at the source. You look at the EPA. The EPA is basically the regulation. The Clean Water Act is the regulation. They are really setting the guidelines on a federal level in which you're kind of looking at proper ways of dealing and disposing of fog and grease with the ultimate intent of preventing the blockages and issues down at those wastewater treatment facilities. They set the pre-treatment standards, right? And those are kind of the standards in which different industries, in this case, it would be the food service industry, kind of what they need to meet in order to comply with regards to reduction of pollutants in our waterways. And kind of the way that they do that too is really, and this sort of transcends through different industries with regards to dealing with water, and that's through best management practices, right? BMPs. And BMPs are really processes or ideas which is really, collectively contributing to an overall effect and reduction of fog. And, it could be through education, it could be through technology, it could be through a lot of different ways that we can then ultimately reduce pollutants. And in this case, fog. And this is at the federal level. So there had to be kind of a mechanism then at that point in which, cities, states, like local jurisdictions could take this and ultimately develop their own programs. And the framework that was created, again, through the EPA was the 40 CFR 403. And this really created the framework for cities and for states to develop what we would call fog programs, right? So, ways that individuals, restaurants, service providers, facilities dealing with fats and oils and greases would be able to comply ultimately with that overarching legislation. And that's done through a couple of different ways. One is permitting and monitoring. So ultimately, if you have a new project, you would have to run through a permitting process where perhaps you would be told, hey, this is kind of what you would have to do to meet compliance. There would be a monitoring piece to it as well. So there would be people out monitoring these different types of pollutant loads and then giving recommendations back to the cities and the states to say, hey, these are where we're seeing issues. One of the big pieces of actually dealing with fog, and you'll see this a lot, and this is kind of where I will start to focus in on our kind of devices and technologies that intercept grease, right, before they get out into the waterways. And then ultimately inspection and enforcement is another big piece of it. And today, and this has probably increased, continue to increase, but there's about 200 plus cities throughout the United States that have very, very focused fog programs. And there's about 35 states that also have compliance for the fog control programs. Yeah, so certainly an important piece of legislation that ultimately is affecting your day-to-day with regards to how you perhaps do business with regards to your restaurants and costs and things like that. So when we look at stakeholder compliance, right, and this is where it gets, and I put this slide together because I think it kind of shows a little bit of the different stakeholders who all have invested interests in dealing with, fog reductions, right? So certainly even in your local level, sewer and water departments, they are ultimately the ones that are having to deal with the kind of the tangible piece of this, right? So the cleanup, the inspections, certainly we have plumbing inspectors, health departments are a big part of this, right? Because at the end of the day, if you've got, dirty water being backed up into your facilities, into your kitchens because of a fog-related issue, this could ultimately sort of lead to health issues with, people eating at the restaurants, things like that. So the health department is certainly a player in this. Plan checks and engineers, ultimately the ones approving the projects, they're obviously looking for compliance around this. And then, certainly your pre-treatment departments as well. So like people looking at where those pollutants are coming from. So, a lot of different stakeholders within this regulatory piece that are affecting your day-to-day. So, okay, you're a food service provider. Perhaps you're opening up a new restaurant. Perhaps you have an existing restaurant, and you're wondering, like, well, how does a city, county deal with this compliance? Well, usually there will be a set of documents. It can be easily found online, or you can go down to your local city. But really, it's a guideline in which you can then look to meet compliance for that individual county, city, or state, right? So, usually it will give you the kind of the why, like why are we doing this? And I think we've gone through that a fair amount. We kind of within those documents, there might be recommendations on the different types of technologies that would help you to meet compliance within that city. So, maybe it's a type of a grease interceptor, maybe it's a type of educational policy that you need to comply with, whatever that looks like. And then ultimately, when we look at the main focus of the industry with compliance, it really does focus around something which we call a grease interceptor, and what these pieces of information will give you is a lot of information around the type of interceptor you could be using. It'll tell you kind of what the plumbing code needs to be. It will also tell you kind of what the sizing requirements are. So really, this is where you can go and find a lot of the sort of the nuts and bolts of what you need to do to be in compliance as well. And this is kind of where we meet, the kind of the rubber meets the road, because at this point you have to sort of pick a device as well. When we look at failure to comply, essentially, certainly there are repercussions, especially when you have a sort of a legislative overlay, right? In most cases with fog, failure to comply is really around fines or penalties. Certainly there is going to be perhaps even a business closure. There are times where, if it's deemed to be a really big environmental impact, you perhaps could have your business closed down. But typically there's going to be fines, different violations until you are within compliance. And this is really a way of cities to also incur or to accrue the actual cost of dealing with fog if it's not being dealt with at the actual source. So something that you could certainly keep in mind when you're kind of thinking through this, that there usually is a cost associated with not being in compliance with regards to fog. So that kind of hopefully gives you sort of an idea at a high level, right, of, fog again as this idea that it is a pollutant that needs to be dealt with. There is a sort of a legislative and regulative overlay that is basically giving you guidelines on how to deal with it and the reasons why. And then ultimately there is the solutions, right? So what are some of the things that the industry looks at with regards to actually dealing with fog and actually impacts you from the standpoint of your kitchen or your food facility? There are a number of different technologies that you'll find in the industry. The most common is something that we call a grease interceptor. And this is essentially something that will actually intercept and hold or contain the grease to prevent it from actually getting down into your piping network or your systems. It's a piece of technology. There are biological treatments, right? So things like enzymes that will go out, bacteria that will go out and kind of break up the fog and the grease. And then there are also chemical treatments. The reason that biological and chemical treatments are not necessarily used is because in some respects, they can also cause issues within the, in pipes, and in some ways can also be a pollutant, right? So really the industry starts to look very, very much at the sort of the mechanical, the actual physical technology of interceptors to deal with grease at the source. That is sort of where I am going to be sort of looking at from the standpoint of the technology in the presentation. So grease interceptor basics, they're sort of different locations. And again, I like to use the word system. I like to sort of look at systems as sort of an organism in some respects. There's pipes, there's networks, there's connectivity. And in a building or a project, you have the interior and you have the exterior. And so there's different ways that grease interceptors can be deployed, right? Sometimes they're deployed right at the source, so at sinks, at dishwashers, before you have the outflow out towards your sewers, or you have like a main containment, which perhaps is outside of the building envelope, usually in ground, and is essentially trapping the grease before it enters in the sewer. The three types of technologies within this category is something we call a gravity grease interceptor, a GGI. We have something called a hydromechanical, an HDI, and then we have something called a GRD, which is a grease removal device. A gravity grease interceptor is essentially, as it says, it's taking grease, water through gravity, moving it down to a large exterior, typically containment, in-ground unit. Water and grease will sit in there and separate. These are units that will typically have to be pumped and the grease and the debris out of these systems. So that's one type of technology. We then have a smaller, kind of more condensed technology called a hydromechanical, an HDI. That's kind of mixing the gravity piece, but adding things of more of a mechanical nature. So maybe it's baffles that helping to separate that grease and water and allowing cleaner water to flow out the one side and grease to separate out the other. In a sense, this is still a containment in which still has to pump and physically remove the grease from the interceptor. And then we have a grease removal device, or a GRD. And this is where you have some technology that through sort of an automatic process is siphoning or removing the grease from the water. And there's a number of different technologies. And I'll kind of dig in a little bit around all three of these. When we look at, when you look at solutions in the industry, let's say you have a new restaurant or you have an existing restaurant or food service facility, one of the, I would say, solutions that I think are quite commonly used are the large GGIs. And a GGI is, as I said, is essentially allowing grease, oils, and not just grease and oils and water, but essentially any of your dirty water. So if you've got like a mop sink or any of that, that all flows down into the same containment facility. These are usually dealing with large volumes and large flows, anywhere from 350 gallons to 750 gallon kind of applications. There's a number of different baffles inside of them that are allowing the grease, the water, and then kind of the solids to separate. And they're usually made out of concrete. Sometimes you have plastic solutions, but usually they're more larger civil type solutions that will sit outside of your facility. And I think one of the things to remember here is that this is not necessarily separating grease out. It's containing it. And what you will still have to do is have some kind of pumping facility or a pump truck come and basically suck all of this stuff out to take away to be further processed as well. It works on settling time. And I think one of the things to remember here is that, to sort of maintain these, to kind of keep up with them, you've got to kind of understand, how much grease is entering into the system. And that kind of be a nuance. It can be tricky, right? And so, there's certainly things to think about. I would say that on some of the pros of these systems, they're simple, right? I mean, they're essentially just a large containment. They're effective for large volumes. I would say overall durable, mostly made out of concrete, though, some of the fogs and some of the bacteria could actually, work away and eat away at concrete. So it is, or cement, or however you want to put it. So something to consider as well from kind of the performance of the system over time. Performance, I think, can decrease over time with these kinds of systems. Ultimately, there's, a low operating cost initially, but depending on how often you have to pump these systems, it can get quite expensive. I've had estimates from anywhere from sort of $700 for perhaps a smaller system, anywhere to about $3,500 for a very, very large system. And if you're filling these things up, it can become an incurred cost to you over time. And certainly some of the cons, like I mentioned, is, sometimes the installation costs can be quite expensive because these are large systems. As I said, there can be performance limitations. And then, environmental considerations as well over time. As we move into the hydromechanical piece of these technologies, this is a smaller system, essentially. As I said, it's still using settling time and kind of the water and grease as it separates, but using more mechanical baffles to kind of work through that. You usually find these within the close vicinity, if not in the kitchen. And kind of the difference here too is that it is still holding and containing the grease. You still have to actually deal with it, right? Which would be perhaps pumping it, and that can also cause kind of delays and issues within the kitchen. There are some jurisdictions throughout the US, some cities that are kind of questioning this particular type of solution, just because they don't want a large pump sucking out the grease, essentially contaminating the kitchen around it. And, something to consider when you're thinking through these solutions. Some of the pros on these, easy, they're fairly inexpensive. They can be durable over time. They do tick a box for most compliance. I would say some of the things to think about when you are considering a solution like this, that they, because they are containing the grease, they can create odor issues. It's not something you really want customers to be smelling or interacting with. Sometimes they can be prone to clogging if you're not keeping up with them, because they're not an automatic removal of the grease. You're not keeping up with them. The first time you're going to see a problem is perhaps in your prep sinks, or and then you have a problem and there's a cost incurred with regards to kind of getting that fixed. So something to consider. And then the last technology is grease removal devices, or GRDs. And these are essentially devices that have technologies that siphon off the grease. They're usually put into some kind of collection device or containment, and then you have an outflow of clean water out into the sewer system. And these systems really work well at removing grease very efficiently on a sort of ongoing basis. I would say that a system like this, it's not a sort of set and forget. You will still need to have training, people who kind of understand that system, do some daily maintenance. But ultimately, it is a very, very effective way of removing grease from the system on an ongoing basis. There's different ways that different manufacturers will kind of do, remove this grease with the GRDs. In this particular example, there is a ball that sits at the interface between the grease and water, and as the water and the grease levels rise, that ball will open up the valve and allow grease to kind of move out into a containment or a catchment. And then, as that grease level reduces, it will allow the outflow of clean water as well into the outflowing pipes. A couple pictures of systems in kitchens, things that you may have seen. Typically some of the similarities in these devices, they will use a heating element to kind of keep the grease and the water from congealing. The hotter the system, the quicker you will have the grease separating from the water, so it makes it more efficient. You will have some kind of catchment in the beginning or filtration that will be catching the bigger debris, because that's not really what you want out in your grease. And then you will have some sort of cassette or some way of collecting that grease to be disposed of in a kind of a safe way. These kind of systems too are really sized depending on what you have going on in your facility. For example, if you have a couple sinks and a dishwasher, it really is flow based, and so most manufacturers will be able to kind of give you the idea of what you will be able to use in that particular kitchen. So, for example, like a sink and a dishwasher combo here, there'll be a certain size that you would then be required to use within the premises. Another piece that is really important to remember is that these things all have to meet a plumbing code. We talked about sort of that legislative overlay. Every city will have some kind of plumbing code that essentially this is an appliance, these separators. And so if you have any sort of electrical or anything like that, there has to be a code with regards to that device. And a plumbing code is a very important piece to this. There's a number of different testing agencies that most manufacturers will align to. Really is dependent upon how big the separators are, the type of technology, but some of them are sort of under the umbrella of the ASME, which is the mechanical plumbing and engineering standards. IAPMO is one that you may have heard of, but really a good way to understand if these devices are compliant is kind of speak to the people who are making them, right? But these are important pieces and will, ultimately, if not in compliance, will not be able to be installed in your facility. We have another poll question.
All right, thank you. We have our second poll question for our audience. And that question is, would your business benefit from upgrading to a more advanced grease interceptor with higher efficiency? And please select one of the following. Yes, definitely. Maybe, if the benefits are clear. No, satisfied with current interceptor, or not sure. That question again, would your business benefit from upgrading to a more advanced grease interceptor with higher efficiency? Please select yes, definitely, maybe if the benefits are clear, no, satisfied with current interceptor, or not sure. I'll just give our audience another couple of seconds to get in their votes. All right, thank you again for voting. I'm going to close the poll and share those results. So we have 50% for yes, definitely, 0% for both maybe if the benefits are clear and no, satisfied with current interceptor, and another 50% for not sure. Back to you, Scott.
Okay. All right, so we're sort of moving towards the end of the presentation, again, to kind of touch on very, very briefly, kind of the why, right? And that was sort of through the reason that, this is a pollutant, right? And this is not only a pollutant to the environment, but it can also impact your business from a cost standpoint. And so, something to kind of consider, ultimately the different types of technologies, kind of where the industry is focused on from the standpoint of compliance. And then, like any sort of industry is really, where is this all going, right? If I have an existing facility or a restaurant, like what are some of the technologies and what are some of the things that may be coming and need to consider? So, as a food service provider, right, you're faced with lots of challenges, right? There's, keeping customers happy, and there's more of like a tactile piece, right, which is equipment maintenance, which is hygiene and sanitation, regulatory compliance, all of these different things that, at the end of the day, you're trying to make money, you're trying to run a business, and you're trying to kind of think, like, how do I deal with this all, right? And so when we look specifically at equipment maintenance, there are things that really the industry is looking at potentially helping with, right? And there's different elements to this. One of the things is looking at enhanced fog separation and recovery. The systems that are, doing the job better, right? Less input, less sort of touches, and so manufacturers, engineers perhaps are looking at ways to do that better. Another big piece of the kind of the future of fog is kind of utilization of this resource, because I use the word resource. This is still something that is still part of a kind of economic value, I would say. And in some ways, people look at this as money. Fog in some respects can be utilized to make biofuels. There are particular facilities that are looking for high quality greases to turn into biofuels or sustainable aviation fuel. Another piece is improved monitoring and control systems, so technologies that are already looking at how you monitor and control. Certainly regulation and compliance is always developing. And then, public awareness and education, right? So giving more information so people are just aware of the impact of these types of pollutants. A big part of kind of where the industry is focused on too, especially around fog, is biofuels, right? And not all fog is made equally. Certainly there are, and I use Costco as an example here. They have separators in all of their stores to basically deal with and collect grease, essentially yellow grease from rotisserie ovens. And they really collect that and separate that to sell, right? They actually sell it to processors who turn it into biofuel, into animal stock. And there was a lot of legislation. In 2022, there was a tax credit that was essentially put out and ready to promote things like increased aviation fuel production and sustainability with regards to fog. So, biofuel is a big piece of the future around fog. And so ultimately the collection of that really high quality grease is going to be a focus. Automation, certainly, like I said, systems in which you have to touch less, right? So things where, perhaps it is, depositing the grease into one container that just gets collected. You don't even have to touch it. Or pump truck comes up, just plugs in, pulls it out, and you never have to touch it. It's just clean, less odors, less touches. This is kind of where the industry is looking at innovating and bringing kind of new solutions to the end user. And then ultimately the idea of sensing technologies, right? So, the last thing you want to have is your sinks banking up or issues within your restaurant or your facility because you didn't know something was happening, right? So certainly innovations in sensing and kind of alerting and giving you, up and current information about the health of your systems is going to be an important piece as well within the in the future. So we have one more poll question before kind of I wrap up and give my closing comments.
Yes, we do. All right, our final poll question for our audience is, which fog control method do you think is most effective? Please select one of the following: public education and outreach, grease traps and interceptors, regular pipe cleaning and maintenance, or advanced fog removal technologies. That question again, which fog control method do you think is most effective? Public education and outreach, grease traps and interceptors, regular pipe cleaning and maintenance, or advanced fog removal technologies? I'll give our audience another couple of seconds to get in their votes. All right, I am going to close the poll and display those results. And I just want to thank our audience again for participating in these poll questions. So fairly simple results here. We have 0% for both public education and outreach, as well as regular pipe cleaning and maintenance. And we have 33% for grease traps and interceptors, but a majority, 67% for advanced fog removal technologies.
Great. Well, that sort of concludes today's presentation. As someone who works in this industry from a day-to-day, I am out meeting with customers, meeting with restaurants, meeting with, perhaps city agencies. There is, there's certainly a lot of focus on this industry, and it's certainly a worthy place to really deal with a major pollutant. I hope that today's presentation really, at least planted some seeds with regards to, how this affects my business. What are some of the things that I can use to be, to contribute to sort of the environmental impact, but ultimately also help my day-to-day business to function and be a contributor. So I really appreciate the time. Hopefully this was informative to you. Kind of gave you some seeds to think about, and I'm really looking forward to some questions. And hopefully, if there's things that I didn't quite explain, that we kind of dig into it and be able to give you those answers.
All right, Scott. Well, thank you so much for your insightful presentation. Now I'd like to invite our audience to continue sending in their questions or comments for the Q&A portion of the webinar. And if you're attending via GoToWebinar, please use the question window. And for those who are watching on LinkedIn Live events, feel free to post your questions in the comments section. So I've already got a few questions, so I'll start with those. So our first question, what's the difference between an AGRD and grease traps?
Yeah, so so if you kind of go to some of the technology, so a grease trap is it's kind of a coin term, right? It's that a grease trap is essentially all of these devices are a grease trap. They are essentially trapping the grease, holding it back. There's sort of different trees of technology that then step from that, and the GRD is really the one that is automatically skimming or removing the grease and depositing it and allowing the water to flow out. And essentially, that is a grease trap. It's just not. It's dealing with the grease in a different way. Some of the others, you're having to pump that debris and that grease out by a physical means, like maybe it's a pump truck as well. So the grease trap, I would say, is kind of the coin term for all of those devices.
Awesome, thank you. Another question is, how often does each system require cleaning or maintenance?
That is a complex question. At the end of the day, it really is dependent upon, how much grease is exiting your system. If you have a facility that is putting out a lot of grease and different debris into your grease traps, probably more regularly than others. Typically you will have documentation from your city that will stipulate minimums, right? That say, hey, at a minimum, you will have to pump your system. Usually there's a rule about 25% of solids and grease in, say, a grease trap before it has to be removed. The GRDs are a little different because they are essentially skimming the grease, and most of them you can actually kind of see when you have to change it out. You're just really just taking that physical grease and either dumping it into a safe containment or into your main collection, and so that you can physically see. But it changes, and I think the other thing is so like, for example, you're a restaurant and you change your menu, right? Maybe you're producing more grease. You have to sort of adjust your systems to meet those needs. But usually there'll be a minimum compliance that your inspectors or your health department will kind of give you kind of the criteria of what you have to do. But I will say this is also where the complexity lies, because if you aren't maintaining them, if you're not focused on these systems, once they block, once there's an issue, there's money, there's time to actually clean them out, and then they could impact your business, right? If you block up into your kitchens, into this is disruption to your business. So it does require the user to be a little bit more engaged with these systems and how often you maintain them. And this is why I also think some of the technologies in the future, where perhaps you're getting more alerts, more things that maybe there's more of an automation to cleaning, where you're not having to be as engaged with these systems as you do today. So yeah, hopefully that kind of gave some nuance around that.
I think it did. Another audience member would like to know, who is responsible for cleaning each system, in-house staff or service provider?
Yeah, so most at the end of the day, if you are a food service provider, you are responsible for maintaining, cleaning your systems. In some cases, especially with the big gravity fed, maybe you will have a contract with a pumper or someone who will actually come and inspect and clean. But at the end of the day, if it does block, or if there's an issue, you are responsible as the end user, right? So it's really up to you to keep an eye on them. In kitchens, especially with some of the in-kitchen, like the GRDs or the mechanical separators, there will be people within those facilities that will be trained in kind of looking, cleaning, and maintaining those systems. But at the end of the day, you are as the owner, are responsible for kind of the maintenance and the scheduling of those systems.
All right, our next question, how easy is it to access and clean the captured grease in each system?
Well, it really, I would say that I've seen all kinds of systems at this point. I've seen systems where, they haven't been maintained, and they are, it takes a lot more effort to kind of clean and collect. The efficiencies of the systems are not there. And so it really becomes kind of a headache. I would say that, with regards to some of the, like the mechanical or the automatics, because they're doing it on a continuous time frame, it's a little bit easier from kind of an overall maintenance standpoint.
Understood. All right, another question. Does the EPA set national regulations or limits for fog discharge from food service establishments?
They do. With regards to, again, when you look at it from a, if you look at it as an umbrella, right, you have that Clean Water Act, right? They're basically created the framework. The EPA is setting the standards, right? And they are the ones that are enforcing it on a federal level. Again, when we sort of kind of break down to like more of that local level, that is ultimately where that's going to impact your business, or what is ultimately going to affect you from a day to day. But yeah, the EPA is continuing to set regulation, and with regards to, I mentioned kind of methane gas, CO2. This is a I wouldn't say a moving target. I mean, the regulation's been set for a while. But as we kind of urbanize, and this is the way that I think about it, right, especially with fog, as we, you get more infill, you get more urbanization, you get more people in a condensed area, you're going to have more and more of that kind of condensed fog, and you're going to need better technologies and better regulation to deal with that. And I think that's probably, when we will see maybe an evolution of some of those, the EPA regulations with regards to fog and other pollutants in our waterways. So yeah.
All right, we've got a couple more questions. One of them, how do these regulations translate into specific requirements for local municipalities?
Yeah, so that really kind of is again around that framework of looking at kind of that point source control. So there is that piece of legislation that really breaks down what cities, what jurisdictions really need to do to comply. That being said, I've been to a lot of different jurisdictions throughout the United States, and each one has a slightly different way of dealing with it. So there is some room for them to develop their own policies. But at the end of the day, that policy has to kind of meet a certain standard, right? How they get there is really up to that city and up to that state. So that's really kind of where you maybe see a little bit of the, let's say you go out to the East Coast, maybe they have a slightly different way of dealing, different compliances to say maybe the West Coast or however that looks. So yeah, there's still some gray areas in which we're working through in this industry.
An audience member asked, grease traps are out of sight, out of mind. What are the benefits of automatic grease interceptors as compared to the traditional grease traps?
Yeah, it's a very good question. I would say some of the in-ground units, because you're not seeing, the kind of the closed lid or whatever it is, you're not really seeing what's happening in there, right? And so, with a lot of the in-ground units, you tend to have, other components contributing to that. So maybe you've got like a mop sink, you've got other wastewater entering into it. And if you're not kind of maintaining it, if there's a blockage, then the first time you're going to see it is in places you don't want to see it, which are in your sinks and things like that. And so because you can't really see it, you don't know what's happening until there's a problem. I would say on the automatic, usually they have, there's like visual cues, right? Because it's actually separating the grease, putting it into some sort of catchment or container. In some cases they're clear. And so as you're kind of cleaning, as you're doing your day-to-day, it's a very easy visual cue to say, oh, that thing needs to be changed, right? Because it is designed for some interaction between the user and the device itself. So yeah, I would say the automatic grease separators are much easier from the standpoint of actually understanding, hey, I need to do something here, than if it's, out of sight, out of mind in some of the others. So.
All right, we have time for one more question. Back to the EPA. So does the EPA provide guidance or best practices for local fog management programs?
They do, and ultimately best management practices kind of where it sits, right? So, I think what they will ultimately recommend is grease separators for this particular part of the industry. I mean, that's where they will try to sort of focus you. But there are other ways with the EPA kind of gives guidance, right? And part of that is just, a big one for me is education, right? I would say if anyone who's listening, just type in fog and click on the Google images, and you will see a host of different educational, like, hey, don't dump it down the sink, this is the way that you deal with it, right? And so certainly EPA is got a number of different ways and different pieces in which they want you to regulate. But the big one for that is they do want it dealt with at the source, right? At the end of the day, they don't want to sit and go to, again, I mentioned the Chattanooga River on fire or the Chesapeake. They don't want to go out there and go, like, we're testing the water, we've got all these problems. They want to be able to go all the way upstream and say, hey, let's deal with it here. And that's really what they'll be focused on from a and into the future as a sort of a compliance standard.
All right, Scott. Well, thank you very much for those answers. We've reached the end of the Q&A portion of this webinar. If we couldn't attend to your questions, the team at ACO may follow up with you, or if you have any further questions, you can direct them to the email address on your screen. Thank you so much, everyone, for participating in today's webinar. You'll be receiving a follow-up email from Xtalks with access to the recorded archive for this event. And a survey window will be popping up on your screen, and your participation is appreciated as it will help us to improve our webinars. Additionally, I've shared a link to view the recording of today's event in the chat box, which you can also share with your colleagues so they may register for the recording here as well. And for those watching via LinkedIn live events, we encourage you to visit xtalks.com to register for this event and gain access to features such as viewing the recording and more. Now, please join us in thanking our speaker, Scott, for his time today. We hope you found this webinar informative, and have a great day, everyone.
Thank you.